Hi, and welcome back to our coding demonstration for abstract classes for lesson 9.5. Hopefully you have your TechSmart abstract classes open. We're going to take a look at that together and build on our knowledge a little bit of what we started with superclasses or inheritance. So some superclasses are only meant to be inherited from, and it doesn't make sense to create an instance of it. If we think back to our animal classification example from inheritance, and we had code for animal kingdoms. Specifically, we talked about a mammal class, and the mammals contained cats, dogs, and rodents that it could inherit from. And that inheritance structure made a lot of sense, but it doesn't make a lot of sense to actually make a mammal. It's not specific enough to actually have enough information to create. So we would call that an abstract class, and sometimes you might also hear it referred to as a base class. It'll tell our program that it's fine to inherit from the class, but it should raise an error if we try to create an instance of it. So one of the benefits might be making sure that all mammals are created in such a way. So if we know we had some properties of mammals, so let's say like they have to eat or they have to have fur or whatever properties of that base class must be true, we can declare those abstract instances or those abstract attributes or behaviors so that the class that inherits from it has to be created correctly. An abstract class can provide methods and attributes to the subclasses, just like we've seen with regular inheritance, but they can also tell subclasses that they have to implement certain methods. And they do this by using a decorator called addAbstract, and we're going to see that here in a minute. We make that abstract method an empty method with a name and parameters, but we don't actually write any code. And in our example, we're going to make sure that all animals can eat. And we're going to define the header for that eat method, but we're not going to tell the subclass how to eat. We're just stating that the subclass has to define that in its own class. Because it's inheriting from this abstract, it must also have the ability to eat. So if you recall how we define and inherit from a superclass, we define the superclass, and then in the subclass, we just put the name of the superclass inside our parentheses when that subclass is defined. So we're going to revisit an old program that could have benefited from having an abstract class. So let's switch over to our code together. Okay. And if you notice, we switch over, we are back to our animal class. It's a version of flight response we explored in past instruction, and it's currently missing some things. So the mole and the tortoise don't have anything when we hover over them. If we run this right now, you see the bird takes off just like it did before, but these two guys right here, they're new. We haven't defined anything for a mole and a tortoise yet. They're generic animals, so they don't have a flea that's specific to them. So we're going to create some specialized classes for each animal's fleeing style, and then we're going to make the animal class abstract. So the first thing we want to do is open up our animal.py. And under the modules section, we're going to import ABC from and abstract method. We're going to say from ABC, import ABC, and abstract method. No spaces, and I don't know why they didn't exercise good notation here and separate that out, but they didn't. So you can find information about abstract if you start typing in your code assist. So I always forget that that's squished together. So I always refer back to that because it never fails. I put the underscore in there, so you can always refer back to your code assist for assistance there. So abstract method from ABC, and then ABC is the thing. So now I need to also include that class animal is a subclass of the abstract class called ABC, and that's what ABC stands for. And by inheriting from ABC, it's automatically made it to where you cannot create an animal. So looking at the animal class, we'll notice that flee method is defined, but it doesn't have anything in here. All it says is pass. That pass, remember, is the placeholder that'll allow code to run, but doesn't actually do anything. Okay, so the only thing we need to do right here now is to tell Python that that is the abstract method that must be implemented by anything that becomes an animal. So we use @abstract method. Okay, it looks just like our property decorator. It starts with the @ symbol, and we notice that it turns bright pink. Now, officially, the animal class is an abstract class. We won't be able to create any instances without using a subclass. Okay, so if we go back to our project and we say flee for all, we're now going to break, and it's going to say can't instantiate an abstract class animal without flee. So it's telling us that we're not done yet. Okay, so we need to switch back to our animal.py, and we need to do a little bit of editing here for our other class. We have burrowing animal. We're going to come down here. I don't know why that's repeated twice. They have a little typo. This one should say slow animal. So if you want to go ahead and fix that, we're going to define two more classes. So we're going to say class burrowing animal inherits from animal. And then we're going to pass. And we're going to say class slow animal inherits from animal. And we're also just going to pass for now. We are going to take that flee for all and replace animal in the second module imported. So we're going to go back to, so from animal, we're going to say up here. And we're going into flee for all. And instead of from animal import flying animal and animal, we're going to say from animal import flying animal, burrowing animal, and slow animal. Okay, we no longer have to import animal generic because we're not going to be instantiating an animal generic. So we're also going to change these. The mole is going to become a burrowing animal, and the tortoise is going to become a slow animal. Okay. Now if we run it, we're going to see that there's still, well, aside from my spelling error, animal. We still have it because it can't instantiate a burrowing animal without the flee. We have not defined the flee yet. All we've done is put the header in there and gave it a placeholder. So we'll go back over to animal. We'll do that really quick. Every animal has to have a flee. So we can steal the flying animal's flee and then modify it for our own purposes. And our image is going to be a little bit different for this one. We're going to say that our sprite.image is images/dirt mound.png, and we're going to hard code that. And we are not moving up and down, so we can delete that Y speed. Matter of fact, our burrowing animal is not going to move at all. So it is not going to get any speed. It's just going to get an image swap and a scale change. So after we've switched to that dirt mound, the dirt mound's a little bit bigger than it was. So we're also going to say self._sprite dot scale equals 0.25. Okay. And then under the slow animal, we'll define that one as well. Define underscore flee self dot sprite dot flip x equals, and for this particular slow one, we're going to flip it around and face it in the same direction, and we're going to give it a slow x speed. Self dot underscore sprite dot x speed equals -35. Okay. If I go back into Flee for All and run it, it should actually let me go, and the bird takes off. The turtle then always departs in the same way, and the mole just becomes a dirt mound. There we go. We have now inherited from our abstract classes and redefined.